Hello everyone, my name is Sultan GAZI and I'm from the MicroDev Team. For our group assignment, we chose to do the automatic safe lock, and we are looking at the diagram or circuit of our automatic lock. The key components of this lock are AHMED 32, which is the 32 pin microprocessor itself, the keypad which is connected from B0 until B6, the audio output which is connected at the B7 port, the interrupt which is connected to the D2, the 7 segment with the register is connected from C1 until C7, and there are 2 LED lights to indicate right and wrong, and with the right one there is one motor connected to it, which are connected to the ports C0 and D7 respectively. Now let us have a look how this circuit reacts if the user presses the password. The correct password for this lock is 1234, which can be set to any numbers later on. So let us have a look how does this circuit react. First of all, we disconnect the interrupt. So if we press 1 2 3 4, the green light lights up and the door is open as the motor starts working. Now let's have a look if how the circuit reacts if user presses wrong password. So let us press 1598, so it's a wrong password, and this light lights up. 3658, still a wrong password, and also we can see the numbers in the 7 segment, still a wrong password, and then 6587. Here you can see if the user presses 3 consecutive wrong password, the buzzer will start playing and also the red light will show. That was the function of this buzzer and also the red light. So now if the interrupt is connected, where here we can see, you can check if the keypad is still working. If you press any number, the 7 segment will show its number 656. So this was the primary demo for our circuit. Now we'll go in details and functionality of the course. Thank you so much for watching.
Hello doctor, I'm Wong from MicroDev Team, and I'm going to explain about the get key function in our program. Basically, the get key function is used to read the input from this keypad to be processed by this microprocessor AHMED 32 and to generate specific output either for the LED 7 display or the LED or motor here. So let us look at the keypad configuration. So for the keypad, first of all we define the R0 to R3 for specific pin here, 0 to 3, and 4 to 6 is for the column pin, and we set the keypad DDR to be DDRB. We also define arrays for the keypad row and keypad column. For the keypad row is R0 to R3, keypad column is C0 to C2. So in the main function here, we set the DDR. For the upper part of the keypad port, which means this here, the row is the upper part, and we set the upper part here to be the output by giving 1 to them. And the DDR for the column here we set as input, so we give the 0 to them. After explaining about the DDR configuration, let us look at the get key function here. So inside the get key function, we first set the DDRC to be output, so we can however, we press here 1 and it will show on the 7 segment display here. So how it works? Basically, it will give the height to particular row at one time, and it will goes to column by column to check whether there's the key being pressed. If for the first row it goes to column by column and there is no key being pressed, it will give the output 1 to the second row and check column by column whether there is the key being pressed. If the key is being pressed, for example, I press 5 and it will start at the R2 R1 for the second row here, R1, and the 5 watt will, since I press this, and the 5 watt will flows inside the second column here, and the C1 which to the B5 pin will detect the input height, and after process inside the program here, that means for the second row, second column, second row is I equals to 1, and it will goes to the Z equals to 0 first. When I equals to 1 and it goes to Z equals to 0 and the key is not being pressed, and it will increase the value of J to J equals to 1, and it will detect that there is the key being pressed, and it will go inside this nested if statement and find the J equals to 1 and I equals to 1. So here I equals to 1, and it will find that J equals to 1 is actually the port C, number 5. So port C here will show the representation for number 5 and delay for 2 milliseconds and return the value 5. This value is returned to store in our program memory and then later used to compare with the correct password later. I think that's all from me. Thank you.
Hi everyone, I'm Andy. For my part, I will explain about the delay and interrupt. The delay will occur when the user pressed wrongly the password 0.5 seconds before the LED light up. See that? And when user press correct password, it will delay for 5 seconds before it turn off the motor. Okay, let's now look at the code. There's two functions of delay. One we use the default library, and one is we create using the knowledge of the timer one. Now let's look at the code of the timer one delay. Here's the function of the delay 0.5 seconds or 500 milliseconds, and the calculation is shown at here. Since we are using 1 megahertz of the CPU clock, the timer one is a 16 bits counter with max count of 65535. That's why we choose timer one, because the total count we calculated is around 62499, and for timer 0 and timer 2 is exceed the limit of 256. Even using the 1024 preschooler is still cannot reach. You can see here 487 clock. And then we choose preschooler 8, and that's because it's acceptable and exact, because the value we get here, the count here does not contain decimal value. And yeah, here's and then the CTC, we're using the CTC mode, and we set the OCR to the count we desire to reach 0.5 seconds, and the TCCR1B is set to 0 times hexa 008. You can see the code here. We set a timer, time 0, count 0, then OCR1A to the count we want for 500 millisecond delay, and we set this one, the TCCR1A 0, TCR1B 0 to set the, this one is to set the prescaler 8. So it's not reached the count until this one. It will wait, and then after that stop the timer, and then clear the OCF1A. Let's move to the interrupt part. Our interrupt circuit is here, connected to the D2 INT0. When 0 low input is given to the D2, it will interrupt and help us test whether the keypad is functioning well or not. Here we press 1, 2, 3, and then we switch on the switch. Then we press 6, it will remain 6, 7, 8, which our password is 1, 2, 3, 4. And when we switch off, it will turn back to where it stopped just now. And when we press 4, the switch, the door will still open, which means our function of the interrupt is working well. And now let's see the code. Here's the code for interrupt, which we're using PD2, which INT0, and when the PD2 is still low, it will function the get key, which I have explained by Wong. And in our main, there's MCUCR and GICR. This set to 1 is to allow the interrupt for INT0, and SEI is to set the flag of interrupt to 1, which allow interrupt. That's all for my part. Thank you.